Good morning, student. Here we are learning chapter number 6, triangles, and it is part number 3. Here that we are going to learn the topic that is criteria for similarity of triangles. Now as we know that the criteria for the similarity of triangle, we know that there are two conditions to satisfy that if the two triangles are similar, then these two conditions are must be satisfied. So let consider, as we know that in previous session we stated that two triangles are similar. Two triangles are similar if their corresponding angles are equal. Their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. So that is in triangle ABC, as you can see here, and triangle DEF is here given. Angle A corresponding to angle D are equal, A and D are equal, B and E are equal, and C and F are equal. As well as the corresponding side ratio of corresponding sides, AB upon DE, BC upon EF, and CA upon EFD. Then the two triangles are similar as given in the show figure. So by this two proof, let we take some theorem, and after then on the base of that theorem we can solve some examples. Let now here you can see that A corresponds to D in the figure, D corresponds to E, and C corresponds to F. Symbolically, we write the similarity of these two triangles as triangle ABC similar to triangle DEF. In congruence, we have taken some other symbol. Here we are going to show, if you want to show that two triangles are similar, then we use this symbol. It is symbol to show that both triangles are similar. So we read it as a triangle ABC is similar to triangle DEF. The symbol stands for is similar to. This symbol stands for is similar to. Recall that you have used the symbol congruent. This is referred to for congruent. So symbol for is congruent to in class 9th, as we know that. Now it must be noted that as done in the case of the congruency of two triangles, the similarity of two triangles should also be expressed symbolically using correct correspondence of their vertices. For example, for triangles ABC and DEF of figure 6.22, we cannot write triangle ABC similar to triangle EDF or triangle ABC similar to triangle FED. We have to must write triangle BAC corresponding to triangle EDF because B corresponds to A corresponds to D, and C corresponds to F. So we have to write in this pair. So we remind these all the things. Now let theorem number 6.3 says that if in two triangles, corresponding angles are equal, there then their corresponding sides are in the same ratio, and hence the two triangles are similar. What if the in two triangles, as you can see in the figure, corresponding angles are equal, then their corresponding sides are in the same ratio. Here you can see that B corresponds to E, both are equal, C corresponds to F, both are equal, and by the angle sum property we can say that this angle of 80. So A corresponds to D. Means here corresponding angles are equal for both the triangle. So then their corresponding sides are in the same ratio. Then we can say AB upon DE is equal to BC upon EF and CA upon FD. So these ratio are same. Hence, we can say that both the conditions are satisfied. That is, angle corresponding are equal and corresponding sides in the same ratio. So we can say that the both triangle are similar to each other. Now, theorem number 6.4. It is converse of that. If two triangle sides of one triangle are proportional to, or that is in the same ratio of the sides of this other triangle, there then their corresponding angles are equal and hence the two triangles are similar. क्या कहते हैं कि अगर दोनों ट्राइंगल की साइड्स की करस्पॉन्डिंग साइड्स का रेशियो ले और सभी सेम रेशियो में हो तो हम क्या कह सकते हैं कि उनके तीनों तीन एंगल करस्पॉन्डिंग एंगल भी सेम होंगे और हेंस both conditions are satisfied, then we can say that the both triangles are similar to each other, and this criteria is referred to as the SSS, side similarity criteria for the two triangles. As we have studied SSS rule, for congruence rule, SSS congruence rule, we have studied here SSS similarity rule for two triangles. If they are given that three sides are or the ratio of corresponding sides are equal, then these two triangles are similar to each other. Hence, you can see that here given two triangles ABC and DEF. Let me take the corresponding sides, the ratio of corresponding side. As you can see here, AB upon DE is equal to BC upon EF and CA upon FD, and each equal to 2 upon 3. You can see that. So, so we can say that both triangle are similar by the SSS rule. So, like now you can measure that angle B, angles A, angle C, angle D, angle E and angle F. You will observe that angle A corresponding to D are equal, B correspondence to E are equal, C correspondence to F both are equal. That is the corresponding angles of the two triangles are equal. Hence we can say that the given two triangles are similar. Now one after then theorem number 6.5. If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, sides including these angle are proportional, then the two triangles are similar. Let us consider the figure. Yes, you can see here one angle A is corresponding to D are equal. You can see that, and the ratio including these angle, the ratio of the side including these two angles, you can see the AB upon DE 2 upon 3 and AC upon DA, that is 4 upon 6, that is 2 upon 3. So we can see that these two triangles are similar to each other. So let this criteria, this criterion is referred to as the SAS, side angle side similarity criteria for two triangles. If there is given one angle is similar to is equal to other angle of other triangle, and the ratio corresponding ratios of the side including this angle in the same proportional, then we can say that the both triangle are similar. Here you may observe that AB upon DE, AB upon DE is equal to AC upon DF, each equal to 2 upon 3, and angle A included between the sides AB and AC is equal to angle D included between the sides DE and DF. That is, one angle of a triangle is equal to one angle of another triangle, and sides including these angles are in the same ratio or proportional. Now let us measure angle B, angle C, angle E and angle F, that you will find that both the corresponding angles are same. So now Let us take some example and solve some example. Let observe figure 6.30 and then find angle P. Here we want to find here we want to find angle P. Angle P. For that, if we want to say that the angle, any of angle from the this triangle is corresponding to this triangle, then we can easily say that angle P is equal to this. But before that, we have to show that both triangle are similar. But we have to show that both triangle are similar, then we can say that the value of angle P. Now let you can see that in this triangle A B and C. So here given angle A, angle B, and by angle sum property we can easily find angle C. It is will be of 40 degree. Now first we have to here you can see that they are given size of all the sides of triangle ABC, and also in triangle PRQ PQR, here also given the sides. So we can take the second condition, SSS rule. Which rule we can take? SSS rule. And then we can say that both the triangle are similar, and hence comparing the corresponding angle of P, we can say that angle of P is equal to. So now solution in the triangle ABC and triangle PQR. AB upon RQ, you can see in the figure, AB upon RQ is equal to 3.8 upon 7.6, which is equal to 1 over 2. BC upon QP, which is equal to 6 upon 12, that is half. And CA upon PR, that is 3 in 3 root 3 upon 6 root 3, which is equal to 1 over 2. Hence, you can see that AB over RQ, BC over QP, and CA upon PR, so that we can say triangle ABC is similar to triangle RQP. And by the similarity, SSS similarity, as we know that, therefore angle C is corresponding to angle P. So angle C is equal to angle P. Hence, corresponding angles of the similar triangles. So we can say the angle C is equal to 180 minus angle A minus angle B, that is equal to 180 minus 80 minus 60, which is equal to 40. So hence we can say that angle P is equal to of 40 degree. Example number 7. A girl of height 90 centimeter. You can see that a girl of height 90 centimeter is walking away from the base of the lamp post. Base of the lamp post means this lamp post is perpendicular to base, and girl also perpendicular to this base. So this angle will be of 90. From the base, a lamp post at the speed of 1.2 meter per second. At the speed of, she is running from point B towards to point with the speed 1.2 meter per second. If the lamp is 3.6 meter above, this lamp is 6.3 meters above the ground, find the length of her shadow after 4 seconds. If she reach here, so we want to find its shadow will be horizontally here. We want to find its length of its shadow, means we want to find DE. Now you can see that if you draw such triangle ABC, and here the CD, so you can find that angle E, you find that here two triangle ABE and CDE, ABE and CDE. So here E is common angle in both triangle, and here B is equal to D. So we can easily say that for by the A8 similarity, angle similarity, because third angle will be same by the angle sum property. If we have B and D and E, then we can say that third angle will be also same. Here angle A and angle C will be same. So by that way we can say that both triangle are similar. So by that similarity we have speed of this girl. So he reached point D from the point B with the speed 1.2 meter per second. So we can find this distance by the speed formula, and we have let we consider that DE is of x meter. So let AB denote the lamp post and CD the girl after walking for 4 seconds away from the lamp post. From the figure you can see that DE is the shadow of the girl. Let DE be x meter. We want to find this length of shadow. Let we consider it is x. So here BD is equal to, how can we find BD? BD is distance that she have walked with the speed of 1.2 meter per second. So by the distance speed formula, speed is equal to given by, as you know, the speed s is equal to given by distance upon time. So this we want to find distance, and give a time is given 4 second and speed is given 1.2. So we can find BD. BD is the length from point B to D. So D will be equal to speed into time. So speed is 1.2 meter and time is 4 seconds. So we can find distance B to D is 4.8 meter. So now, note that in triangle AB and triangle CDE, angle B is equal to angle D, each of the 90, because lamp post as well as the girl are standing vertically to the ground, and angle is equal to angle, same angle. Hence, by the AA similarity criterion, we can say that triangle ABE is similar to triangle CDE. So therefore, we taking the ratio BE upon DE from the triangle BE upon D and AB upon CD. Here we can see that BE is the sum of BD plus DE, that is 4.8 plus x upon DE x, AB that is 3.6, and CD that is 0.9, because 9 centimeter is equal to 90 upon 100 meter, which is equal to 9.9 meter. So let we can find the x. 4.8 plus x is equal to 4x, 3x is equal to 4.8, and hence x is equal to 1.6. So shadow of the girl after walking for 4 seconds is 1.6 meter long. So by this way we can solve such examples. So let's consider some more example from the exercise. So let exercise number 6.3. State which pair of the triangle in figure 6.34 are similar. Write the similarity criterion used by you for answering the question, and also write the pair of similar triangles in the symbolic form. So first let's consider one figure. Here you can see that ABC triangle and PQR triangle. Now you can see that here let us consider, you can say that AB, if you take AB upon QR, AB upon QR, then 2 upon 4, that is 1 upon 2, BC upon RP, BC upon RP. So you can see that 2.5 upon 5, that is 1 upon 2, and PQ upon CA, that is AC upon PQ, that is 3 upon 6, which is equal to 1 upon 2. So you can easily say that A is correspondence to Q, B is correspondence to R, and C is correspondence to P. So by that way, SSS similarity rule, we can see that both the triangles similar. Solution. So A is correspondence to Q, B is correspondence to R, and C is corresponding to P. So we can say triangle ABC similar to triangle QRP. Hence by the SSS similarity criterion. So by this way, such we can, here you can see that M is correspondence to Q, 70 are equal, and you can see that ML upon QP is equal to, we can take ML upon QR, ML upon QR, 5 upon 10, that is 1 upon 2, and Mn upon Qp, that is 2.5 upon 5, that is half. So by the which criterion, SAS criterion, we can say that both the triangles are. So here M corresponds to Q, M corresponds to Q, and L corresponds to R and N corresponds to M. So we can say that yes, SAS rule, side angle side rule, triangle M corresponds to Q, N corresponds to P and L corresponds to R. So we can say triangle M and L is similar to triangle QPR. As well as you can solve such example as you can see here. Here you can see that D is correspondence to P because by the angle sum property it is 80, it is 30, then it will be 70. So D corresponds to P, E corresponds to Q and F corresponds to R. So hence we can say that solution. Yes, by AA rules, triangle DEF is corresponds to triangle APQR. So by this way, you can say that using the similarity criterion, you can solve such examples. Now let consider one more example. Example number 2. In figure 6.35, triangle ODC is similar to triangle OBA. Let us consider the figure. Yes, you can see that triangle ODC corresponds similar to triangle OBA means OR equal in this triangle. D is corresponds to D is corresponds to B, and C is corresponds to A. C is corresponds to A. Means D equal to B, O equal to O, and A equal to C. And angle CDO is of 70, and then find angle B. Here given also BOC is of 125. So find DOC and DOC, DCO and OAB. Now here you can see that BD is a one line. So here COB and COD are linear pair of angles of linear pair. We can say that. So we can find COD. Here you can see that DOB is a straight line. So sum of both the angles DOC plus COB is equal to 180. Hence we can say DOC is equal to 180 minus 125, that is equal to 55 degree. It will be 55 degree. Now about angle C. By the angle sum property we can find angle C in triangle DOC, angle DCO plus angle CDO plus angle DOC is equal to 180. Sum of the measures of the angle of triangle is 180. So hence we can find DCO is equal to 55 degree. Here given that triangle ODC and OBA are similar. So easily we can compare angle D with एंगल बी और यहाँ पे गया है कि ओ ए बी सो वी कैन कंपेयर ए विथ सी in given that triangle DOC is corresponding to triangle is similar to triangle OBA, so we can compare triangle OAB is equal to triangle OCD. Corresponding angles are similar in this similar triangle, so angle OAB is equal to 55. Hence we can solve such example. So let solve such examples from the exercise number 6.3. There are given question number 1. Show that the given triangles are similar to each other by the given any criterion, similarity criterion. So by solve that,